Hello everyone, welcome to Sources classes. This is Tushar Shaw, and in this video we will be continuing to solve the UPSC CS Main 2020 paper that we were solving since the last 8 videos, I guess. Okay, so I've already told you enough about how subjective questions work, so I won't be explaining it to you in this video. Probably I'll remind it to you in the next video. So let us dive into the questions directly without wasting any time. Okay, so in the last video we did up till question number 4C. Okay, so in this video we will be starting from 4D. Okay, so question number 4D says that the complex NiCN whole 4 complex NiCN whole 4 2 minus is diamagnetic and NiCl whole 4 2 minus is paramagnetic. Okay, paramagnetic, that is because of presence of unpaired electrons. Okay, so we have to explain the observations and deduce the structure of these two complexes. Okay, so let us just firstly write down about how the structures are there and how this diamagnetic and paramagnetic differences are coming. Okay, so firstly you must need to know that NiCN whole 4 NiCN whole 4 2 minus system is a square planar structure. Okay, is a square planar structure that is also derived derived from octahedral structure octahedral structure after Z out JT distortion, JT, or you may say Jan Taylor distortion. Okay, so let us firstly discuss about the NiCN whole 4 2 minus, and then we will be discussing about NiCl4. Okay, so now Ni2 plus system is both in there, is there in both the cases. Now Ni2 plus obviously has is a 3D 8 electron system. Okay, electron system is there. Now for the octahedral or the square planar, whatever we may consider, let us draw the energy profile diagram for the system, and then you will understand easily. Okay, so yeah, so in this case Cn minus obviously is a strong field, again very strong field. So firstly pairing up would take place. Okay, yeah, yeah, so as I was saying, uh, this would be the initial octahedral species. An octahedral species would be forming this kind of complex, this kind of energy profile diagram. But what happens is, because of the Z out occurring, now why the Z out occurring, the Z out is occurring, that we won't be discussing. That is a different topic, and that is not the concern of our question. Okay, so because of this Z out occurring, this kind of splitting takes place. Okay. So let me just write the exact representation for you. So this one is the barycenter obviously. Okay, now this would be having a set of pair of electrons, this would be having pair, and both of these electrons would be coming here, leaving this orbital without any electron. As in this case the all the electrons are paired up, so this would be giving a diamagnetic performance. Okay, diamagnetic magnetism. Okay, so this would be diamagnetic, and in this by this we prove that the Ni2 plus in this Cn, the Cn cyanide complex in this case would is octahedral structure, was an octahedral structure, that is it had the coordination number 6, 4 minus, then Z out occurred, Jahn Teller distortion, giving NiCN whole for 2 minus system as the square planar geometry. Z out occurs in this case, like let me just draw the structure for you. M Z Z Z Z. The plane, the four ligands in the plane remain as it is. And the axial bond, that is the ligands in the axial bond, they elongate and move out of the system. Okay, both of them elongate and move out of the system. They are released, and this one is also released. Okay, so this way the Z out occurs, and this is why the only from the octahedral the square planar structure is achieved. Okay. Now, in case of Cl4, now let us write question the part number 2. That is, in case of NiCl4, Cl4 2 minus. What happens is, firstly, this structure is obviously 3d8. 3d8 is the electronic configuration of the Ni2 plus system. So this has a tetrahedral geometry first of all, and secondly, Cl is a weak field ligand over here. Okay. So for a tetrahedral geometry, let me draw the energy profile diagram. So firstly, sorry, the electrons would take up as the Cl minus is weak. Firstly, filling of electrons would be occurring, and then pairing up would occur. So two electrons are there which are unpaired. Okay, unpaired electrons are present in the system, and therefore this shows magnetic behavior, that is paramagnetic in nature. The above energy profile diagram is is there for the square planar one. Okay, the square planar complexes, and this one is for the tetrahedral complex. Okay. This let me just draw the orbital names for you: dz square, dx square minus y square. This one is the dxy, dyz, dxz. Okay. So this is the case. Yeah. So this question is done. Let us move on to the next question, which would be probably the last question of this video. Uh, yeah. So question number 4e. So it says that why are DD electronic transitions forbidden? Why are they weakly absorbing, and why do they occurring? Why do they occur at all? Okay, so this takes us again to the rule that we have already discussed in the previous classes, previous lectures. Obviously, while I was discussing this paper only. So the rule that is named as Laporte's rule. Okay, Laporte's rule. In this video, I will be explaining it in detail. Not so much detail because obviously already we have discussed in detail in the last video, second last video. Okay. So Laporte's rule. This rule says that in a centrosymmetric environment. Now you may be asking, what is a centrosymmetric environment? So I have already taught you in my earlier videos about the topic stereochemistry is already completed. Okay, so you might be knowing about the center of symmetry, that is I. Okay, center of symmetry I, you already know it. So in a centrosymmetric environment, that is in a molecule having the center of symmetry I, the electronic transitions will be occurring occurring in the energy levels of opposite parity. Okay, so transitions will occur in opposite parity, that is G to G. This is not possible. U to U is not possible. U to G is possible, and G to U is possible. Okay. So obviously the Laporte rule is not followed in case of DD transitions. Why? Because the for maximum octahedral complexes I is missing in the case. So here the Laporte rule is not followed. That is the compound is Laporte forbidden. Okay, Laporte forbidden, and therefore DD transition is not feasible over there. Transition is not feasible over there. Okay. Now another rule is there regarding the spin multiplicity, but I guess that rule. Let me just open the question paper. So that rule obviously is not asked because the only just the transition is forbidden. Like that thing is asked only. Okay. So we won't be discussing the spin selection rule obviously because this does not even involve the DD transitions. Okay, so the Laporte rule is now explained. I'll just explain why it is the Laporte rule is sometimes relaxed. Okay, so relaxation of Laporte rule, relaxation, relaxation of Laporte rule. Okay, this rule says that when some transition metal ions form complex, it is surrounded by ligands, and some mixing of D and P orbitals may occur. Okay, mixing of D and P orbitals may occur. Okay, so in this case the transitions are when mixing of D and P orbitals occur, then the transitions that occur are no longer purely DD transitions. Okay, transitions that occur are no longer pure DD. Okay, no longer pure DD transitions, and therefore as the centrosymmetric environment is hence somewhat achieved, therefore the Laporte rule is relaxed, DD transitions are exactly possible, and therefore some color is imparted to the system. Okay, relaxed relaxed Laporte rule because of somewhat somewhat presence of I. Okay, the centrosymmetric environment is somewhat achieved in the octahedral complex, and therefore this kind of relaxation occurs. This is known as the vibronic coupling. Okay, vibronic coupling. The name of this relaxation is vibronic coupling, and this causes color in compounds, color in compounds which are Laporte forbidden. Laporte forbidden. Okay, so this was all about this question. I guess up till question number 4 is completed, and then we'll be moving on to section B. Up till this was the section A. Now section B has kind of easy questions, but they are also the level is somewhat easy, not so much easy, and obviously marks is also there, 10 marks per question, so it will be a lengthy one. Okay, so let us wrap this video up. I guess we'll be meeting in the next video, and then we'll be starting section B, and then we'll be completing. I guess more 6 or 7 videos will be required, and then we'll be completing that. Okay. So thank you.